Welcome back to the deep dive. So, if you were sitting there staring at, this just sprawling list of AI models,
Oh, it's endless.
it is GPT-5, Claude, Gemini, Mistral, and you're just trying to figure out which one is the absolute best fit for your next big custom infrastructure project, well, you're in very good company.
And it's so much more than just a model choice now, isn't it? It's really a foundational architectural decision.
It really is.
I mean, especially when you're building something very specific, like a high-performance MCP server.
A multi-context processing system, right?
Exactly. Designed to handle all these diverse, simultaneous tasks. The wrong model choice can instantly bottleneck your entire operation before you've even started.
Exactly. And that pressure to choose correctly is just immense. So our mission today is to give you a definitive shortcut.
A framework.
Yes, a framework. We took a deep dive into this exhaustive comparison of the whole AI landscape, stacking up the proprietary, the closed source giants against the most popular open weights contenders.
And we distilled all that analysis down.
We did. We distilled it down into a three-part framework designed to help you select the best AI model for your custom MCP server build based on its specific function.
And that's the key, right? We're moving beyond just general performance scores. We identified three critical application-specific indexes that really define a model's utility in a custom server environment.
So it's not just about what sounds good on paper.
Not at all. You need a model that doesn't just, talk the talk, but one that actually executes the core task your server is meant to perform day in and day out.
And those three critical indexes, the ones we're going to unpack today, are the agentic index
The intelligence index.
and, of course, the coding index. We're going to show you where the clear winners lie in each category, and maybe more importantly, what those scores actually mean for your deployment.
But before we even get into dissecting the scores, I think we have to acknowledge the fundamental trade-off that everyone faces when they start designing a custom system.
So it's the classic dichotomy, isn't
It
it?
is.
The high-performance, lockdown, proprietary model versus the flexible, transparent, and, often locally deployable open weights option.
Right. And those proprietary models like GPT-5, they often represent the absolute peak of current AI performance.
So they come with strings attached.
Big ones. You introduce vendor dependencies, higher costs tied to API usage, and of course, potential data privacy concerns. What's crucial is that you're often just getting an API endpoint.
You can't really look under the hood.
Exactly. You can't truly peek under the hood or fine-tune them with your own proprietary data without a massive effort and significant cost.
Which is where open weights comes in.
Open weights models, on the other hand, offer you full control. You can deploy them locally on your own infrastructure, which is just essential for an MCP server that might be processing internal, highly sensitive data.
And you get that open source compatibility.
Right, and the ability to fine-tune them deeply for very specialized tasks.
But, okay, the conventional wisdom has always been that you pay for that control with a dip in raw power, right? If I'm building, say, a high-frequency analysis server that needs to process and act on data in milliseconds, am I handicapping myself by choosing flexibility over maximum performance?
Well, that used to be a much easier question to answer. It really did.
And now,
Now, the open weights community has closed that gap significantly. The key, I think, is to stop looking for the fastest or the biggest model and start looking for the model that minimizes the performance hit in your most critical function.
so focus on the 90% use case.
Precisely. If your custom MCP server needs elite-level reasoning 90% of the time, that's where you focus your budget and your attention.
So the core decision point for you, our listener, the custom builder, is this. Are you willing to manage potential API costs and vendor lock-in to achieve that top proprietary performance baseline?
Or is the flexibility, the auditability, and the local control of an open weights model worth potentially sacrificing a few points on those overall benchmark scores?
And we're going to help you quantify that sacrifice.
Let's start quantifying that right now. Let's look at the first metric, the agentic index.
Okay, when I hear the term agentic, my mind immediately goes to simple instruction following, but you're talking about sophisticated orchestration. Can you break down what that actually looks like for our builders?
Of course. Think of the agentic index as measuring the model's ability to act as the ultimate manager.
The manager. I like that.
It's not just about following a single instruction. It measures the model's capabilities for strong, autonomous decision-making and complex task orchestration within these multi-step systems.
And that's mission critical.
It is, especially if your MCP server is going to run unattended workflows, resource allocation, and crucially, autonomous error recovery.
Okay, so give me an example. If my financial modeling server fails, an API call 5 steps into a
A 12-step analysis chain, for example.
right. An agentic model should recognize that failure, maybe allocate resources to fix it, or try an alternative path without a human having to step in.
Precisely. And in the proprietary arena, the distinction here is very clear. GPT-5 leads the pack. It's specifically noted in the analysis as causal high.
Causal high, what does that mean?
That term is vital here. It signifies the model's exceptional understanding of cause and effect. It doesn't just execute the next step. It understands why the previous step failed and what the ultimate consequence of its next decision will be.
And who else is up there?
Claude is right behind it, rated between a 4 and 5.
So that strong decision-making, that advanced reasoning, that's what you need when the agent system has to make a tough call under pressure.
Yes, but that kind of reliance on a single proprietary vendor, it introduces risk.
Right, so where do the open weights models stand if my server needs that robustness and, auditability?
The open weights candidates here offer tremendous proven reliability. GPT-3 really stands out. It's rated high in this category, and it's joined by Quinn.
Okay, GPT-3 and Quinn.
And they're known for robustness, meaning they handle these complex, multi-step tasks without crashing, and for offering greater transparency, which is non-negotiable if your server handles compliance-heavy workflows.
So they might not have the same smarts for recovery, but they're stable.
They provide excellent agent task handling. They focus on stable, predictable orchestration, even if they might lack some of GPT-5's, let's say, cutting-edge error recovery sophistication.
So the implication here is, if my custom MCP server's primary function is high-level automation task chaining, resource management, I'm choosing between the powerful autonomous error recovery of a GPT-5 or the proven highly flexible robustness of GPT-3 and Quinn.
That's a great way to put it. That's the choice.
That's a really great distinction.
So we've covered the manager, but a manager is only as good as the information they process, right? We need to look at the pure intellectual horsepower.
Which brings us to the intelligence index.
Exactly.
The intelligence index. This seems to be the one that everyone focuses on when they talk about the big AI breakthroughs. What exactly is this metric measuring beyond just, sounding smart?
Well, here we're evaluating models based on raw reasoning power and pure abstract problem-solving abilities.
Okay.
Think of this as the philosopher, or maybe the research lead.
Ah, I like that.
This is what's required for tasks that are inherently novel, complex, or require synthesizing knowledge across completely disparate domains.
So an agentic model organizes a known process perfectly.
Right. But an intelligent model can figure out how to solve a problem it has never, ever seen before.
This is where the benchmarks get interesting again.
Mm.
Who's leading the proprietary pack in just pure brain power?
The leaders are probably predictably GPT-5, which is rated as ideal high, and Claude 4.5.
Ideal high, another key term.
A very important one. It signifies that these models are perfectly suited for zero-shot learning, so tackling new problems without specific, tailored examples, and for deep analytical work, things like complex pattern recognition or novel knowledge synthesis across massive data sets.
So if your server is designed to find those hidden connections in data, these are your front runners.
No question.
That makes sense for heavy data synthesis. Now, GPT-3 scored highly in the agentic index, and here it is again, rated ideal in intelligence within the open weights category. So for the listener, what is the practical difference between agentic GPT-3 and intelligent GPT-3? Why this double strong showing?
That's a fantastic question, and it gets to a critical source of confusion for a lot of people.
Right.
Agentic GPT-3 is strong at following that 12-step financial analysis chain reliably. That's the execution.
Got it.
Intelligent GPT-3 is strong at figuring out the right 12 steps in the first place, especially if the input data changes radically. It's the model's core ability to process new information and derive the correct conclusions.
I see. So in the open weight space, you still get excellent reasoning power with GPT-3, ideal, and also Gemini 1.5.
Correct. Both are specifically known for their advanced knowledge processing capabilities. It's really comforting to know that going with open weights doesn't mean you're sacrificing fundamental brain power anymore.
No, not at all.
And this is where you, the custom builder, must check for relevance. If your server's core function involves intelligent query processing, pattern detection, or solving genuinely novel problems, then the intelligence index should carry the heaviest weight in your final decision.
You're prioritizing the aha moments over just reliable task execution.
You've got it.
Okay, we've covered the manager agentic and the philosopher intelligence. Now we need to discuss the hands-on aspect, the people who actually build and maintain the system. Let's talk about the coding index.
Right, because every custom server requires custom code, and more AI models are integrated directly into the development workflow for, well, for everything from prototyping to debugging.
Everything.
The coding index assesses models based on their raw coding capabilities. It's measuring output quality, speed of generation, and how effective they are in solving programming issues.
Efficiency in a development cycle is everything.
Yeah.
So who dominates the proprietary world when it comes to generating clean, functional code?
GPT-5 High and Claude 4 are the clear leaders here. They aren't just giving you code snippets, they're acting as highly sophisticated enterprise-level pair programmers.
A pair programmer in your pocket.
A very smart one. They excel at handling massive code bases, providing highly efficient suggestions, and, critically, solving complex programming issues very rapidly. If speed to deployment is your #1 priority for your MCP server,
Which it often is.
especially if you're integrating new languages or APIs frequently, their efficiency is just unmatched.
They reduce developer downtime significantly. But, as we mentioned earlier, many custom MCP server builders are prioritizing open source compatibility and transparency, especially if they're building community tools or working with specialized hardware where, vendor-specific constraints are just prohibitive.
And that's the key distinction. For openweights, GPT-3 High continues its reign of versatility. It's a workhorse for coding assistance.
It's everywhere.
It is. But it is joined by Mistral, which is rated as medium in this category.
It's true. Okay.
Now, while Mistral's raw scores might be slightly lower than the proprietary leaders, it is a phenomenal dark horse. It's incredibly efficient for scaffolding and for rapid code generation when you just need a functional template to get started.
I love that dark horse analogy. It suggests Mistral might be the perfect choice if you need, punchy, fast code generation for a specific open source project where you prioritize lightweight deployment over, say, maximum debugging power.
Exactly. The choice here really reflects your fundamental development philosophy. You go with proprietary models for maximum efficiency, robust debugging, and handling massive complex code issues.
Yeah.
Or you go with open weights models like GPT-3 and Mistral for maximum compatibility, rapid prototyping, and adherence to open source project needs.
Okay, let's unpack this and bring it all together.
Right.
We've covered the 3 vital performance indexes: agentic, intelligence, and coding.
Right.
And we've seen GPT-5 consistently ranking at the absolute top of the proprietary pile, often setting the benchmark. Causal high, ideal high. It's the undisputed champion of pure raw performance.
It is. But I think the real revelation in the data is the sheer versatility of the open weights leader, GPT-3.
It scored high in agentic
Ideal in intelligence.
and high in coding. It really proves that you no longer have to make a massive performance sacrifice to get the benefits of open source deployment and customization.
That gap is closing fast.
So how does the listener synthesize all of this? They have a custom MCP server to build. The goal isn't just to pick the model with the highest average score.
No, absolutely not. The goal is to identify the single greatest bottleneck in your server's planned function. The best model is the one that provides a tailored solution for that primary need.
So it's about specialization.
It's all about specialization. If your server is mostly task orchestration with minimal novel reasoning, you can likely choose a high agentic, maybe medium intelligence model and save on resources.
But if it's a deep research platform,
Then intelligence must be maxed out, even if that means slightly slower code generation during development.
by reviewing the proprietary versus open weights models through the precise lens of these 3 benchmarks, you now have a framework to match performance profiles to your specific server purpose.
You're prioritizing based on quantified need, not on hype.
Yes.
And that's the power of a deep dive into structured source material. It turns a really complex decision into a guided prioritization exercise.
It really does.
And understanding these trade-offs is what turns a good custom server into a truly optimized, focused machine.
Absolutely. This framework gives you the clarity to navigate that, often very tricky selection process. You've got a distilled view of the entire landscape now.
And as you move forward with planning your custom MCP server build, we want to leave you with one final thought, something based on the sources we explored today, something to consider as you prioritize your resource allocation.
Okay, let's hear it.
Given the strong dual-threat performance of GPT-3 in that open weights category.
It's excellent at both managing tasks and deep reasoning.
Right. So if you only have the limited resources for a single, highly tuned model instance on your custom server, where should you invest? prioritizing the brain or prioritizing the hands.
That decision. Wow, that changes everything about your server's ultimate capability.
The question is, do you want a reliable planner or do you want a powerful problem solver? Choose wisely.
That is a perfect note to end on. Thank you for diving deep with us today. We really hope this framework helps you build the perfect custom MCP server.